you can click on the link below to watch the previous part.
So let's see how we can implement that. Let's write a brute force approach, and then we can initialize our map to optimize it from 2 raised to the power n to O of n solution. We can start by defining our helper function dp, and we said we will take indices and a boolean flag which is true or false. So let's call it even. And so for the base case, if our I equals to nums dot length, we could return 0. Then we should calculate our total. So if it's even value, we can just do nums at, if it's odd, we can do negative nums dot. And we have to return the maximum of total. So whatever the total would be, if we added the number with total, that means now we are in the odd side of things, like we have to subtract. So for that, we will recursively call with I plus 1 and not even. So that means the next value, this will make sure the next value will be subtracted. So, and for the other side, we can just pass DFS with I plus 1 and even. So this will make sure that we will add for the next time. This completes our helper function. Now we just have to return the helper function with our base case, which is 0 and true. So this is the brute force solution. Now how we can optimize it? We can initialize our DP with an object, and instead of directly returning, we can set the value to our DP, which is something like this I, and we said we will do even odd. So all of this value could be this, and we can return our DP here. But here we are assigning the value to our DP, right? Before doing that, here we can check if our DP exists. If this exists, we can just return this itself. Now let's try to run this, and that's all you need for your optimization. So we optimized from 2 raised to the power n to O of n solution. So let's run it. Yep, this works. Hope you found this helpful. If yes, you can consider subscribing to the channel. And thank you so much for watching.